Welcome to Engineering State of Mind, where as always we elaborate engineering and technical aspects in a simple and understandable way. The aircraft is a marvel of science, a masterpiece in engineering, and a great work of art. In previous videos I've explained some parts of the airplane, but today we shall look into the heart of the beast causing thrust, i.e., the jet engine. There are many types of jet engines, from the turbojet, the turbofan, turboprop, and turboshaft. These are all gas turbine, and the most common in airliners is the turbofan, which we shall look at first. The wing may cause lift, but without the energy of thrust you can forget about long-haul flight. The only exception are gliders, which need some other form of energy to commence, but basically engines are important, unless you use some other form of energy to propel the aircraft. There are many parts of a jet engine. These components, I shall cover all in the next series of videos, especially the next one, which shall be all about how a jet engine works, so stay tuned. Anyway, today we are going to play aircraft mechanic and do some overhaul and assemble. The first component is the outer cover that forms the engine cowling. It made to enable aerodynamics and designed to open easily to allow maintenance. Moreover, it has capability to adjust itself easily for reverse thrust, either target bucket, clamshell, or cold stream, which has cascade or pivoting doors. The second part is the inner cover. It acts more like a cover to embody the inner parts of the jet engine. It is aesthetically built with aerodynamics. It has fasteners that lock the compressor at the front and the turbine, which keeps the engine compact and rigid. The third is a rim that covers the front of the jet engine. It should be noted that this external parts, including this, are designed to allow aerodynamics and reduce drag. Next is the nose cone of the jet engine. It is built in front of the fan and has many reasons, including directing incoming airflow and reducing drag. It also has a swirl in front of spiral shape that scares birds away and prevents them from flying into the engine. Next is a bushing that holds the fan blade in place and enhances smooth rotation. It is followed by a case covering the fan blade, i.e., the fan in front of the jet engine compressor. It is aerodynamically designed at an angle that directs airflow in a specific way to the compressor blades. The bearings allow smooth rotation of the shaft or spool depending on which engine. If you don't know what spool is, stay tuned, it shall be covered in an animation in my next video. The bearing also has a case. It aids in mechanical advantage, i.e., it is easier to propel the shaft with a bigger case. It is built with blades that aid in aerodynamic flow. Now we go all the way to the back, our next component, which is the end cone. It aids in streamlined flow of exhaust, minimizes turbulence, and maximizes thrust capability of the jet engine. Rear case, i.e., it is more like the bearing case in front, but with a little design difference. It has blades that aid streamlined flow of exhaust out of the turbine compartment. The next is a turbine bracket, the mechanics of which shall be elaborated in next video. But this is part of the turbine that enhances rotation of the fan in the front that allows the pulling of air to the compressor. This is then followed by a turbine case for covering purposes. The intake bracket is next, and it allows for the intake of fuel and allows combustion to take place after ignition. Intake case follows, and it allows fuel to enter intake bracket, though pipes in an array around the jet engine. Compressor case is next, and ensures the compressor is well secured and compartmentalizes each part in it as a section of the engine. Central mounting shaft is a shaft in the middle of the jet engine that connects the compressor to the turbine. Compressor bracket holds the compressor in it and has blades that direct air in opposite direction to the blades of compressor. Rear mounting shaft is one that drives the turbine blades at the back. It is located at the rear part of the jet engine. Compressor blades are next. They are multiple and go at different sizes in a reducing state for compression. Turbine blades follow and are also multiple and go at an increasing size state for thrust. The turbine blades create thrust that propels aircraft forward by energizing the compressor in front of it to suck in more air via a shaft or spool. Feed fuel pipe is a pipe in the jet engine comprised of an array of many that allows fuel to enter the intake bracket via the intake case, through holes. Now to sum it all up in an assembly, the rear case and the compressor bracket are connected via the central mounting shaft. The compressor's case, the compressor bracket, and compressor blades form compressor compartment. The intake bracket, the intake case, the pipe feed fuel array, and the ignition all form combustion chamber. The turbine case, the turbine bracket, the rear case, the turbine blades all form turbine compartment. The end cone forms the exhaust. The bearing case, the bearing, the fan case, The bushing the nose cone and the front rim are all form intake, and they enhance the smooth flow of air to the compressor. The inner cover and outer cover provide enclosure and form engine cowling. All these components form the turbofan jet engine. But it should be noted that there are many types of jet engine. This is just one of many. They use the same working principle, only that some have more concentric shafts than others, hence the name 2-spool, 3-spool, and so on. Well, all this shall be covered in the next video. Till then, if you like the content, don't forget to subscribe, like the videos, share, and please click the bell icon for notifications.